right, we're live. Okay, so there's where we left off yesterday. And I stole a little section from the textbook. I just wanted to kind of read through it with you, just to kind of put together some of the ideas we were talking about yesterday. So we didn't use the same example that they did, but we found the slopes of secants that approach a tangent more and more closely. If a curve has an equation y equals f of x, to find the tangent to the curve at the point P is a comma f of a, we first have to consider a nearby point, and we just call it Q, and then compute the slope of the secant P to Q. And notice that this formula right here is just basically our slope formula, right? This is y2 minus y1 over x2 minus x1. And we have to select point Q different from point P because we obviously can't have a and x be the same number because you can't divide by 0. But if we get infinitely close to x and a being next to each other or being the same point, if I shrink the difference between these two points on the x-axis so that this secant gets the 2 points between the secants here, the 2 points on the curve, get closer and closer together. Well, if I start moving Q closer and closer to P, eventually I'll get this blue tangent line. And this process of calculating a quantity by estimating it, then making the same estimate more and more and more accurate until it's exact, is what we call determining a limit. So this is what we call limit notation. We're going to see a lot more of this, but basically the slope of the line is the limit as x gets closer and closer to a. That arrow means approaches a. And then this is just the slope formula, y2 minus y1 over x2 minus x1. We call that formula 1 in limit notation. And let's do one more example of it. So you might want to jot this down. Find the slope of the tangent to the curve y equals x squared plus 2x minus 1 at the point 2, 7. So I'll give you a sec to jot that down. Okay, so we're missing a couple people. I hope people remember that it's late start day. So let's see. 1, 2, so there should be somebody in the back corner. There we go. So we're missing a few people, and we have a new person joining us who I want to make sure that they have a place to sit. So let's see. No? Okay, and I'll stop this while we do O Canada. Or do we do O Canada on Wednesdays? No, I don't think we do we? No. All right, so now I'm just going to make a sketch of this. I just put up a grid to make a sketch. Oh, we are going to do O Canada. Okay, I'm going to pause the video. Okay, we're back. Okay, so like I said, jot that question down, and that should be pretty familiar, right? We've done lots of parabolas in grade 11. I'll go through this example the first time as if I'm not going to use a graphing assister like Desmos. I'll just do this kind of the old-fashioned way, let's say. But I'm still going to use some technology to help me, and I'll show you what I mean by that in a few minutes. Okay, so if I wanted to do a sketch of this, and I do want to do a sketch of it, it is much easier to kind of visualize these if you have a sketch in front of you. So if I want to make a sketch of this, and it doesn't have to be a really accurate sketch or anything, but I do kind of want to know maybe what this parabola looks like. I do know that its x-intercepts would not be nice integers because that doesn't factor. Right? -1. What two numbers times to make -1 and add to make 2? No such numbers. So the roots will be irrational. So forget the roots. Let's use the vertex to find this. So quick complete the square on that to find the vertex. Y equals x squared plus 2x plus 1. But there is already a -1 there. And I'm going to minus another 1 because I added 1 there to the equation. So I have x plus 1 squared minus 2. So I have a vertex of -1, -2. Okay, so let's put that in the graph. So 1 over and 2 down, there's my vertex. And again, my x-intercepts are going to be somewhere between the dots. I'll just count. So a parabola, the a value here is 1, so I know my parabola goes up 1 over 1 in both directions. And then it goes over 2 and up 1, 2, 3, 4. And then it goes over 1, 2, 3, and up 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm counting on a really small thing, so I hope I counted that right. And then let's take this point and move over 1, 2, 3, 1, 2, 3. And come on, pen. There we go. And let's move this one over 1, 2, 1, 2. And there we have it. That's my parabola. So just make yourself a sketch of the parabola. And we know that the parabola is going through the point, we'll call it P of 2, 7. So 2 over, if I drew this accurately, I should hit that point. Pretty close. Yeah, I did hit that point. So this is P of 2, 7. And then I'm going to use some point Q, and I'll call it x, and x squared plus 2x minus 1. So where's Q going to go? I don't know. You can put it wherever you like. It started down here maybe at x is 0. So there's Q. Oops, I didn't mean to put that in a bracket. There's Q with coordinates x comma x squared plus 2x minus 1. And I am looking for this secant line. So there we go. Hello there. Good morning. Somebody is in that desk. There's actually 2 desks that are still empty in this class if everybody's here. The corner over there and the middle back row. So pick one of those, whichever one, and hopefully you can see from there. Welcome to the class. We have a new person joining us today. And okay, there we go. I'm ready to start doing some slope calculations now. So what I need to do now is I need to pick some points. Now, when you get these questions in the textbook, they usually tell you what points to pick for this x value. And then your job is to figure out the y values and then figure out the slope. Let's actually find an actual expression for the slope. So slope between P and Q, come on. The slope between P and Q is y2 minus y1 over x2 minus x1, right? That's the slope formula from grade 10. But this here is going to be x1 and y1. And this guy here is going to be x2 and y2. That's going to be my coordinates. So running that through the slope formula, I'm going to get x squared plus 2x minus 1 minus 7 all over x minus 2. Okay, so let's simplify that. That's going to be x squared plus 2x minus 8 over x minus 2. And unlike the example we had the other day, I see something fortunate about this expression. What do you notice about it? Any thoughts? Yeah, there's people going, well, I could work with it like that. I could start putting in, yeah, thanks. I could start putting in x values and figuring out the slope. But do you notice that this x minus 2 is actually a factor of the numerator? Thank you very much. Okay, so I'm actually going to factor it. So the numerator factors to x plus 4, x minus 2. there we have it. So that's going to be x plus 4. So my slope is just going to be x plus 4. So that's a nice, easy to work with slope. Okay, so now, like I said, most textbook questions now will tell you what x values to use in point Q to start making Q closer and closer to P. And it's a nice, easy slope formula to work with. So here we go. Here's how we'll do this question. Well, let me just shrink that a bit so it fits on the screen. So I actually stole this from a textbook where, yep, it gave me the chart and wanted me to fill it out. So, okay, what happens when I use an x-coordinate when this Q has an x-coordinate of 3? So on my graph, I can kind of imagine sliding Q up to where x is 3, which would actually put it above point P, right? So I'd be approaching it from coming down from above. So 3 plus 4 would make a slope of 7. And then what if I get closer coming down? Remember, I'm trying to eventually get to the point. Remember, my goal is to find the slope at this point P. But I can't just put 2 in for the x-coordinate because then it would make this denominator 0, and it doesn't exist. It's like, well, I can put it in there. Yeah, you can put it in there. You're right. But we are trying to get this by estimation. So 7, and then 6.5 would be the next one. And if I move to 2.1, I'd get 6.1, then 6.01, then 6.001, then 6.0001. I think what's happening is what I can kind of tell if I'd have just put, if I'd have let x equal 2 in the slope that I've simplified, I think I'm going to get a slope of 6. That seems to be what's happening when I approach it from the point above, and I get closer and closer as I move point Q down. What if we start with Q down here, which is kind of where it is in the diagram, and move it upwards and get closer to 2? Okay, so what happens when I start with an x-coordinate of 1? Well, then my slope would be 5, and then it'd be 5.5, then it'd be 5.9, 5.99, 5.999, and 5.9999. As you can see, once again, my conclusion is, therefore, at f of 2, slope is very much going to be 6. All right, so that means that's basically my A question, right? Find the slope of the tangent to the curve at the point 27. Done. Question A is done. Now, determine the equation of the tangent. Okay, well, if I want the equation of the tangent, so that's the equation of this purplish line here that should be straighter, obviously. It's the slope of a tangent. So for part B, how do I find the equation of the tangent? Well, I use this point slope formula that you learned back in grade 10. And I know the slope. I just figured it out. And I know that point P was, of course, 2, 7. So that's y minus 7 equals 6 times x minus 2. And that's good enough if all I want is the slope answer in point slope form. But most textbooks want answers in standard form. So I'm going to just go through and then rearrange. Remember that standard form should always have integers for the constants and coefficients, and the leading coefficient on x should be positive. So move everything to the other side of the equation, and you get 6x minus y minus 5 equals 0. Okay? All right, so that's an example of one that actually works out really easy because the slope simplified really nicely for us. They don't always do that, right? I don't always get a nice, easy to plug numbers into slope. And in this case, I could even plug in the forbidden number of 2 that I couldn't plug in back over here because I'd have had to divide by 0. So this method will work even when I can't simplify it down to something where I can plug in the number I'm looking for. And that's the way you're going to do the questions that I assigned in 1.1. I do think you can use technology to help you, though, especially for things like these calculations. Again, this was an easy one. I picked an easy one. Um, but feel free to use the technology to help you. I put a little video on yesterday to show you how you could, for example, fill in all these chart numbers using Excel. Right? You can just run the formula over and over, and you don't have to sit there and punch buttons on your calculator for 20 minutes. It's very nice. I also don't mind if you use Desmos to do the work for you. So let me show you how I would do this question on Desmos. Okay, so I'll just kind of go through. This is pretty similar to what I did in the video I posted yesterday. But I'll just sort of talk my way through it. Okay, so I'm going to go to Desmos. And there we have it. Okay, so the first thing I'm going to do is I'm going to find, put in the equation that we're looking at. And the equation is y equals x squared. And on Desmos, you get a superscript by just going Shift 6. And then, is it plus 2x? Yeah, it's plus 2x minus 1. Plus 2x minus 1. So there's the graph that we made. And we want the point. And to make a point, you just have to actually open brackets. I like labeling the point, though. So I'll use point P, which is the same thing I called it in my notes. And then that was 0.27. Oops, that's supposed to be a comma. There we go. And if you click on label, it puts the point on your graph for you so that you can actually see it. Which, there you go, 27. Okay. Now, I want a point Q that I can move around. So how do I make a point that I can move? Well, I can't use specific numbers. So for point Q, I am going to say I want Q to be some number. I'll use A. Right? I've already got an X and I've already got a Y, so I have to pick a different letter. So I'll pick A. And comma. Now the Y the Y coordinate of A is going to be whatever A is when I run it through this formula. So what I'm going to do is, instead of calling this Y, here's the importance of function notation. If I call this f of x instead of y, notice it doesn't change the graph any, it's still the same graph, but now I can tell Desmos, oh, you know what I want for this coordinate here? I want whatever the number a would be when I run it through this formula. So I don't have to type the formula over. I can just say, tell me what f of a is. And then it's going to ask me, would I like a slider? And I'm going to say, yes, I'd very much like a slider. And that allows me to change a to be anything that I want. Right? And what did we start with? We started above, right, when a was 3. So that's off my screen, but that's how we started, right? We started with a of 3, and then we found the a. And you can actually just enter the numbers now. You can actually just put a thing here where you can actually figure out what is f of a. And right now, f of a is 14, which you can kind of see if I put it up there. There we go. I guess if I labeled that, it would tell it to me too, right? Oops. Go back. There we go. So f of a is 14, but what if... oh, hang on, sorry. And there we go. Move me over here. There we go. Okay, I can change that a to, what was the next point that I wanted? 2.5. And there we go. That tells me what the number is. And then the next one that we did was 2.1. There we go, 7.61. So there we go. There's all of the numbers that I needed. Now, I didn't even write those numbers down. I went right to the slope. So let's do that too. Let's get the slope happening. So what's the slope formula again? Well, it's m is equal to, and I want y2 minus y1. So what is y2 in this case? Well, y2 is this number here, which we called f of a, right? So that's going to be f of a, and then y1 is 7, so I'll just go minus 7. And to make this a divide, highlight it, and then hit your division button, which is the slash. And there you go, it makes it an over. And then I want the x coordinate of point Q, which is just the number a, minus the x coordinate of point P, which is 2. And there we go. There's the 6.1. And again, as I now change my a value to whatever I want. Again, what did we start with? We started at 3. Right, there we go. And we got a slope of 7. And then when we made it smaller, we made it 2.5. we get a slope of 6.5, and then there we go. I don't have to punch those numbers through my calculator over and over again. Desmos pretty much does it for me. Okay, one last thing that it's nice to be able to do with Desmos is, what if I want to actually see this secant line? Okay, well, again, I'm just using the point slope form of an equation. So I'm going to give myself one more thing here. I'm going to go y minus, and I guess it'll be 7, right? Because I want the tangent at this point here, point P, equals, and then I want the slope. Now I just say m for slope, and the program remembers that, oh yeah, we defined m up in this line up here. So that's the slope, and then it's x minus 2, and there we go. There's our, right now it's a secant, right? Again, if I move this point, you can really see that it's a secant line. There we go. You can definitely see it's a secant line now, right? It's a line that crosses the curve twice. But as this gets closer and closer, you'll see that the slope gets closer and closer to being 6. 5.3, 5.4, 5.5, 5.6, and the closer I get, the closer it becomes 6. So there we go. You can do other things. I kind of always like my tangent line to be dotted so that it's easier to kind of stand out. If you want to do things like play with the color or the texture of the lines, you just click on the settings tab here, and then just click on whichever one you want to change. I kind of like that dotted, so I tend to make those dotted. I think that's what I did in the video too, right? And there we go. And another thing you can do that's kind of fun is you can actually animate this. So I kind of, going all the way to -10 seems kind of extreme. How about I just go from -1 to, well, okay, again, we went all the way up to 3, I guess. So let's go up to 3. So there we go. And then click on here, and it'll actually animate it for you. So it'll take the point there and take the point all the way around to there. And you can kind of watch what's happening to the slope. You can slow that down if that's going too fast for you. And so when you're doing your homework for 1.1, I highly recommend you play with Desmos and start graphing these things, especially when you start graphing ones that aren't maybe functions that you're familiar with. Like we've seen enough parabolas in grade 11 that you're probably all sick of parabolas. But how are you with x cubes, right? X cubes don't have to always be the same shape. Whereas, you know, parabolas are always parabolas. Okay, so I just wanted to do one more kind of like what we did yesterday, but maybe slow down and show you how I got the numbers, because yesterday I just wrote numbers down and tried to explain what the numbers meant. Today I thought I'd just slow down and show you how I got the numbers. Any questions? I didn't really have time to take questions yesterday. Okay, that's all I wanted to show as a lesson, so I'm going to stop my little video. I haven't done attendance yet.